beyond just the Navy, Gamma is intended to be in an economic engine effectively for Guam. And so what I mean by that is, um, of course, we are solving the Navy's problems. Like that's what we're there to do, but we want to do that in a way that's also beneficial to the island. And so that basically means education. It means jobs. It means skill sets, things like that. Funneling, financials and economics down into the local population of Guam to find
Right.
another sort of leg to the stool, if you will, of the economy.
Half a day. It's your innovation coach, Rob Jackson, and welcome to another edition of the Innovate Guam podcast, the podcast where we explore all things innovation, technology, and improvement related to the island of Guam. Don't forget to subscribe and follow me on YouTube, Facebook, LinkedIn, Instagram, and Substack. My podcasts drop at the beginning of each week. Also, be sure to check out my Innovate column in the Pacific Daily News every first and third Friday of each month. All right, our guest for today's episode is leading one of the most exciting and innovating projects in Guam's entire history, Gamma, also known as the Guam Additive Materials and Manufacturing Accelerator. Alex Benham currently serves as the director and general manager of the Guam Additive Materials and Manufacturing Accelerator, or GAMMA, for ASTRO America. ASTRO America is the Applied Science and Technology Research Organization of America. And I tell you, I've been trying to get him on the podcast for a while now. So I am so excited to have him. Here's a few highlights from his background as well as his current role. He's a seasoned 3D printing and defense manufacturing leader with deep additive manufacturing experience across leading companies and organizations. He's held jobs in engineering, sales, business development, and program management. He has a master's in mechanical engineering from the Stevens Institute of Technology and holds numerous professional certifications across multiple functional areas to include product marketing, product management, and additive manufacturing quality assurance. Ladies and gentlemen, I give to you Mr. Alex Benham. Alex, welcome to the podcast.
Hey, Rob, thank you for having me. I'm glad we were able to finally make this happen.
Yes, I tell you, as soon as Astro and Gamma came up on my radar scope, I have been a cheerleader and an excited fan of everything that you all have been doing. And I've been wanting to get you on the podcast for a while. Now that things are starting to come together, you have a location and all of that, and we'll talk about that a little bit later. I'm glad that we can finally make the podcast work.
Yeah,
Yeah.
for
So we
oh,
got a we've got a little bit of a tradition here on the podcast. We start off with some icebreaker questions, kind of get a sense of where your head is at in terms of innovation. So tell me, Alex, what's your definition of innovation, and what does innovation mean to you?
that's a good question, Rob. So I mean, I would say that innovation comes a lot. It comes about in multiple different ways, multiple different skill sets are necessary to achieve that. But I guess what I would boil it all down to is that you have to be able to make something, whatever it may be, in life faster, safer, or just simply better, like, better than it was before. And it usually comes in the form of faster, safer, cheaper, something along those lines. Um, and it tends to show up in places where resources are limited. If you have every resource on the planet, you don't really need to innovate because you have, tons of money, tons of time, and so you don't need innovative solutions. When you're up against the wall and you are resource strapped, that's when you need creative solutions that solve that faster, safer, cheaper sort of, solution that you're trying to find. And, as I mentioned earlier, you need a diverse group of people to do that. Different backgrounds is usually what I mean by that, different skill sets. Every once in a while, the accountant's going to have an idea that the engineers have been overlooking. So you
Right.
need you need those different skill sets and those
A
different people on the
cross-functional
team.
team.
Exactly, exactly. And then I guess to end that out, it's also a little bit dependent on, the leadership in a company as well. Well, I guess it could come from anywhere really, but in my background from a company, and it's having that sort of culture built into the company to ask, why not? Why
Yeah.
can't we make this better than the status quo? And again, just to reiterate, to solve not necessarily to solve problems that don't exist yet, but just make things faster, safer, cheaper, that has an actual impact in somebody's life. Because if it doesn't really make an impact for somebody, you're kind of just doing it for fun, and it's more like a hobby than than
Yes.
a than a actual innovation. Not to say, you didn't solve anything good, but it didn't really it doesn't really amount to anything that impacts anybody. So that's kind of where I would draw the line is something innovative has the impact on people um, or the world, not necessarily just,
Yes.
yourself. So yeah,
Yes. So I consider you a true expert in the field of additive manufacturing. Uh, Tell me, what got you into this area, and so far, what's been your most surprising or mind-blowing aspect of additive manufacturing?
sure. Yeah. So how I got into this back in college, which seems like forever for me for me ago, but it's about 15, 17 years ago, depending on what date you want to pick. I was studying, engineering, studying manufacturing, and that's what my degrees are in. And I was actually working at a traditional manufacturing plant building primarily medical devices, but some hydraulic systems as well. And it was all
Uh-huh.
traditional manufacturing. And I started to understand the limitations of design and designing for manufacturing.
Mm,
And right about that same time, 3D printing was getting pretty hot in marketing in terms of the hobbyist style printers that were out. And about that same time, this is probably 2011-ish, is when I switched into my first role in 3D printing, and I've never looked back. And over that time, as you mentioned, I've worked for a handful of different companies doing really crazy, advanced things in additive, way beyond what you'd see on hobbyist printers, and really pushing the limits of what's possible. So I've built medical implants that are,
mm,
presumably they're in people's bodies right now. I don't actually know. I've built parts for um, satellites that, again, as far
mm.
as I know, are out in space right now. I've built some fun stuff for myself, of course, little things to, make desk ornaments of, little video game characters and such. I would say though, probably the most interesting thing well, I didn't personally build it. So the most interesting thing that I've been involved with, which is on the quality assurance side of things, was actually producing SpaceX helmets. So I don't know how familiar
Mm.
you are with that, but with the astronauts SpaceX, everything that's on that person's body is custom fitted to them, including the helmet, and every single helmet's unique. So I had the
Wow.
pleasure of working on a quality assurance tool to ensure that there were no defects inside the helmets effectively that were 3D printed. So that was very cool. And I got to try on some pre-production versions of them too, which, of course made me feel like a kid in a candy store. So that was awesome.
Yeah, how cool is that? Yeah, absolutely. So, you're a new arrival to Guam. Uh, you've never been to Guam before, Gamma, right?
That's correct. Yeah. My
Oh,
first time over there was October 23, I think. 2023.
uh-huh.
Yeah, and it was part of the Gamma program. And so I made the move over there around September of 2025 now. Oh, I might have got that date wrong. It was October 24, not 23. But yeah, so I'm here now.
So tell me what surprised you most about Guam, whether it be culturally, professionally, or anything, since you're a new arrival to the island.
Yeah. So I would say the thing that, so I like nature, and so obviously Guam's beautiful and the weather there is incredible. You know, sometimes you get the big tropical rainstorms, but then it ends in a beautiful sunset in the afternoon. Um,
Yes.
but honestly, for me, like the lizards, there are so many lizards in Guam, and they're so tiny and they are so fast. Like I love catching lizards, and I have not caught a single one since I've been here. And so that was a big interesting thing for me. On a cultural point, uh, the people in Guam are so welcoming. You know,
Mm,
on my first week there,
yes.
I went over to Chamorro Village, and I ended up talking to somebody who I met on one of my first trips to Guam, and I was like, I was just mentioning, hey man, I'm new here, like I don't really have any friends, and he was like, oh, that's not a problem, I'm your friend now. Like it was it was kind of almost like it just instantly solved the problem. Like now I have friends. Okay, easy enough. So they just really bring in and latch
Yes.
on and
Yes.
make you part of the family, which is really cool.
Yes.
Um, from a professional side, especially on the parts that I'm working on with the Navy and everything like that, is I guess it's not only professional, but uh, the difficulty in the supply chain of getting stuff to Guam,
Mm,
and I can
yes.
I can kind of relate this back to yeah, when I was early on when we had some students from Guam go to Danville, Virginia for training uh, who are actually now our interns, but when they were in Danville, they messaged back to us and we were saying, what is it you like about, being in Danville? And the guys were like, oh, Amazon, you can get stuff in 2 hours. And they were like, there's no chance you could do that in Guam. There's no Uber Eats, blah, blah, blah. And like, I thought they were being, hyperbolic about it. And then I got there and I was like, man, it takes a long time to get stuff here.
Yes.
And which I guess is the entire
Yes.
point of why I'm there now.
Yes.
So yeah, yeah. Um, so yeah, I'd say there's all that, and from now, I just spent a little over 2 months there on my first, long-term stint, and I came back here to the States for the holidays, and I really like I used to love cold weather, and I tell you what, man, I got home and it was like 60 degrees outside, and I was like, it is freezing cold. I did not think that I would acclimate to the heat so quickly. And like we mentioned earlier at the top of this, I'm in Colorado now, and it is cold out here, but it's a dry cold. And
Yeah.
I brought, I mean, there's tons of jackets at my house, so like not a problem. But it's way colder than I would thought it would be, previously living here too.
Yes, yes, yes. Great insights. And I tell you, that's my number one thing about Guam, the welcoming of the people. It's really no exaggeration. Like you could just meet somebody and literally they will invite you to their house for a meal or over to a party, and immediately you become like family. And that's probably the best thing that Guam has going on. The people are just absolutely amazing. Yeah,
Yeah.
absolutely. Innovation leaders, it's your innovation coach, Rob Jackson here. Are you ready to elevate your vehicle fleet operations? Fleet Solutions is an AI enabled fleet management system. Fleet Solutions provides real time video, smart analytics, and total efficiency. Keep your people safe and keep your business moving forward faster than ever before. Fleet Solutions, arriving tomorrow, today. Visit thefleetsolutions.net or call 671-988-9748 to schedule your personalized demo and revolutionize your fleet operations today. Yeah, so let's kind of get into the meat of what we're talking about here. So, if you could set the stage for the listeners who might be hearing about gamma and additive manufacturing for the first time, we're going to start at kind of the 30,000 foot level about, what gamma is and what additive manufacturing is. We'll start off for, how would you describe gamma when you're talking about it to someone who's never heard of gamma before? How do you describe it to them?
Sure. I think probably the better way to start that question is kind of the backwards of how you've phrased it. Start with 3D printing and then talk about gamma, or additive
Yeah, that's
manufacturing and then
probably
talk
good.
about gamma. So, uh, you know, I guess for people that aren't familiar with manufacturing as a whole, right? I guess everything in your world, right? I'm sitting at a desk right now. The desk was manufactured. There's a computer in front of me, a mouse, a phone, a water bottle, another phone, a wallet, a notebook, a light fixture. All those things were manufactured, and they've manufacturing has, been around for thousands and thousands of years, and it's mostly been, you put things together and then you cut away from it. And so traditionally, when we talk about manufacturing, when we talk about a single component, we talk about it in the subtractive manner. But really, like that terminology of additive or subtractive didn't really exist until, or well, at least I wasn't aware of it until 3D printing came around, where it's only additive. And then people started to see the dichotomy of how one works or the other, where you add pieces together to end up at a final result, rather than starting with um, a block of material and cutting away to get to a final result. So, um,
Right.
traditional manufacturing is that second one where you start with a larger chunk of material and you do some operations to it. You carve it, you cut it, you hammer it, whatever, to mold it in the shape that it needs to be. Additive is kind of the opposite of that. You start with nothing and then you add little pieces of material to it wherever the material needs to be to eventually build up a component. And there's a lot of different ways you can do it, which we might get into later on. But that's the really the crux of it is, to do subtractive manufacturing, you have to have a starting point. For additive, you start from nothing and go to the end. And for Gamma, again, the Guam Additive Materials and Manufacturing Accelerator, our objective, which is funded by the Navy, is to help the Navy build um, any parts that, well, really any parts that they deem necessary or critical to their ships in Guam. And the reason we're doing it in Guam is because it's so far away from the mainland US. And so if you think about it, if a ship has an issue, and we just talked, a couple of minutes ago about the logistical hurdles, if you will, that Guam faces just from Amazon, which supplies millions and millions of parts and has a massive distribution network. When you're talking about ships from the Navy, that there's probably like of any one model of ship, there's like 10 of them maybe. So there's not a
Yes.
lot of duplicate parts made for these 10 different ships. And so there might potentially be some parts sitting in a warehouse somewhere in the mainland US. Um, it's probably been sitting there for 50 years and they've either lost track of it or nobody knows that it's there or just not there at all. And so the
Hmm.
point of Gamma is to address those supply chain constrictions where they are happening. It's like a point of need solution is kind of how we put a phrase to it, a point of need. And so in Guam, where there's a lot of military activity, especially Navy, when they need parts, our job is to provide those parts, regardless of what they are, or within reason of what they are, maybe is a better way to say that. Um, so we are doing that, and we're not just a facility. It's well, I mean, at a very simple level, we are a facility, but at a broader perspective, we are building a capability in Guam. And the hope, because we're doing it so far removed from traditional supply chains and through traditional, or sorry, mainland US, is that we can kind of bridge the needs of the Navy and industry there in Guam, where the need is, and address
Hmm.
it with
Hmm.
local resources and people and things like that, without the need of the long supply chains coming from the US. So it's beyond just the Navy. Gamma is intended to be in an economic engine effectively for Guam. And so what I mean by that is, um, of course, we are solving the Navy's problems. Like that's what we're there to do, but we want to do that in a way that's also beneficial to the island. And so that basically means education. It means jobs. It means skill sets, things like that. Funneling, financials and economics down into the local population of Guam to find
Right.
another sort of leg to the stool, if you will, of the economy. And
Right.
I would say that's a pretty good overview of what we're doing. I might get lost in the weeds a little bit, but I think that covers it.
No, it's great overview of both gamma and what additive manufacturing is. Really great explanations that the layman could understand about what's going on here. So, can you talk about some of the main technologies you'll have at Gamma? Like, for example, are you really just dealing with polymers? Are you talking about metals? What kind of metal, mediums are you going to be printing in?
Sure. So our primary target is metals. So most people that talk about 3D printing, they're very familiar with the sort of extrusion-based polymers. The hobbyist style ones, those are the most popular because most people have seen those. We're
Yes.
talking about industrial solutions, and again, primarily targeted at metals. We will have some plastic solutions as well, but we are primarily targeting metals. So it's just again because of the application where we're working in and what the Navy needs is big metal parts that have rusted out over time or corroded or broken for whatever reason. They were overloaded. Um, and we need large, robust metal parts to sustain whatever that application is. So what does that mean from a technology standpoint? We have two major types of metal additive in our facility, or we will have it. It's still being built up. So the first one is called directed energy deposition. So you'll either hear me call that DED for short, or wire DED, or just wire. Um, in effect, I mean, it's actually quite a simple technology. You take a welding torch, like any standard welding capability. It's a MIG welder, and you put it on a robotic arm, and then you let that robotic arm trace the profile and the infill of whatever the part shape is. So if you imagine if it drew a circle and then it drew a circle again and again and again on top of itself,
Mm,
eventually that circle would become a cylinder. It may take, a couple hundred layers or cycles of drawing that circle, but eventually it will get some height in the Z direction and it'll just keep going until you make the cylinder the shape that you need it to be. That's the first technology. Um, the second, which personally I I like more because you can do more detailed work with, is called laser powder bed fusion, or LPBF for short, or just powder. So you might hear me throw out those terms. So laser powder bed fusion, or LPBF, the name, or I guess the action that it does, kind of like all your kitchen appliances, your refrigerator, it kind of tells you what it does in its name. It uses a powderized material to fuse together into a shape. And so if you imagine, I always kind of use cooking analogies as well. Uh, if you imagine the flour, if you're making a pizza or, a cake or whatever, and you have flour
right.
in the kitchen, flour is powderized wheat, right? It was a plant at one point. It was a seed. Somebody smashed it up a bunch and be turned into a powder. We can do the same thing with metals, although the process of getting there's a little different. But we have powderized metal, and it's almost the same kind of consistency as what flour is, but instead of being wheat, it's titanium or steel or aluminum.
Mm,
And so we lay that powder out on a metal surface, and we do it in a very, very thin layer. It's usually around 30 microns, which I don't know what that compares to a human hair, but I'm pretty sure it's smaller. And then we shoot it with a high-powered laser, and that high-powered laser welds those metal particles or fuses them together. And again, if you take that same idea of a circle, and if you just draw with the laser a circle, put more powder, draw with the circle, and you do that a couple 100,000 times, eventually you end up with a cylinder, and you can kind of let your brain run wild from there and expand from a cylinder to really complex shapes like like I said, like a mouse earlier, or an impeller that you would find in a ship or in a plumbing system, or brackets, other things like that, rocket nozzles, etc. Like the shapes can get way more elaborate, but the cylinder kind of is just a simple understanding.
Right,
In
right.
Yeah, and in both of those technologies, we have a wide array of metals. Um, Most of them will be marine grade alloys, so you could think anything that's corrosive, uh, I guess has really good corrosive properties. So you could think like stainless steel, you could think nickel alloys, you could think of uh, cobalt. You could think of a couple other things as well. So we have a bunch of different alloys, aluminum. Earlier, I mentioned that one that we are working in. Beyond that, in the polymer section, we will have the same kind of technology I mentioned a little bit ago, where it's an extrusion head laying down a polymer. Those polymers can, range all over the place. They could be flexible polymers like TPU, which is a urethane type of polymer. They could be ABS, they could be PLA, they could be PEC, PEEK. They could even have infills of carbon fiber or fiberglass, um, all for different purposes. Like some we might want flexible, some we might want really strong, some we might want really dimensionally stable. There's all different reasons that you would pick a certain polymer or a certain metal. But those will be the primary additive technologies we have. Beyond those, because 3D printing and additive manufacturing it's not magic. So you always need secondary operations to do finishing steps. Coming out of the
Yes.
machine, there's always something else. Nothing in the world ever gets made by one single step. So we'll have secondary steps like CNC machining, like heat treating, like sandblasting, cutting, like with a bandsaw, all those types of technologies, which are more traditional in nature than the additive side. We will have that as well. And then the last thing we'll have, which is probably the most unique thing and probably potentially the most important thing, is our testing and evaluation capability, which falls under the quality
Mm,
assurance and quality control.
yes.
So there's a common saying in manufacturing, and if you're not in manufacturing, you might not know it, but if you can't measure it, you can't build it or you can't make it. And basically what that means is you have to be able to prove what you've made is what you've made. So if I
Yes.
tell you, if I build you a widget, and let's just use the impeller example, and if people don't know what an impeller is, it's kind of like a fan. It's kind of like a fan that typically moves fluids like water around. So it's not moving air, but it's moving a thicker medium. Um, and so if I build you an impeller and I tell you, Rob, that this impeller is 2 inches wide and it's made out of stainless steel, how do I prove that to you? So we have a bunch of different equipment that's used for measuring that can tell us it's not exactly 2 inches, but maybe it's 2.05 inches. And depending on your application, maybe you needed it to be anywhere from 1.95 to 2.05. And that's getting a little technical there, but it's a lot of numbers to follow.
No, it's
But as
it's it's a good manufacturing understanding of it, the application to the technical piece of this. So it's really good. But go
Yeah.
ahead with your example.
Yeah, so in all types of manufacturing, when you are measuring something to prove that you can make it, those are called tolerances or allowables. And the measurement is just a simple one, like a physical measurement. That's a very easy one for most people to comprehend. So you can grab your tape measure, and that usually measures at sixteenths of an inch, which is 0.625 inches. We have equipment that measures down to 0.001 inches, so we can get very, very precise measurements. Beyond that, we also have the capability to, on this, like if I tell you it's stainless steel, I can actually do a metallurgical sample, which is, I think in this case, it would be actually spectros it's a spectrometer is what it's called. I don't know that like the fancy name for it, like, but you use a spectrometer which measures the actual constituent elements that are inside the metal. So it would tell you
To
the
prove that
percent
it's stainless
iron.
steel. Yeah.
Yeah, it would tell you the percent iron, the percent copper, not copper. What's the other C one? Carbon. It would tell you, how much molybdenum, how much nitrogen, whatever, all these different elements that would be inside and define what stainless steel is. We can tell you within the allowable bounds if we are stainless steel. And we have a bunch of
Yes.
different other technologies beyond that that could say, stainless steel is allowed to hold we can measure how strong it is. So it's like, how hard does it take to pull apart, or how much pressure does it take to break it? And stainless steel has all these specific allowables that we are able to measure to verify that anything that we build is actually what we say it is. And so it's the
Okay.
testing and evaluation, which is an extremely critical part of any manufacturing operation that we're building on Guam, uh, which as far as I know,
Absolutely.
doesn't exist for thousands of miles outside of Guam. So
Yeah.
it's
Yeah.
a very unique skill set.
Yeah, absolutely. So let's take it back up to 30,000 foot level because I
Sure.
love going into the technical details like we were doing, but I want to go back up to 30,000 foot level. Can you talk us through kind of the origin story, if you will, of Gamma? How did this idea go from, just a bright idea somewhere all the way to execution? And talk about the governor of Guam's role in this to bring it here to the island and how you went from idea to actual execution on the ground now.
Yes, certainly. So a little bit, some of this kind of predates me, so I'm gonna have to, you're gonna have to skip a couple months here and there in the story. But so sometime around 2021, the governor actually through some of her connections was looking through, which is 2021 is right when COVID happened. So the economy in Guam, which, as far as my understanding is military construction and tourism. And one of those two just kind of evaporated in 2021. It was the tourism. And the governor was looking for something else that they could differentiate the economy with. And so through some of her connections, she ended up talking to my boss, Neil, and they were kind of asking, is it possible for Guam to become a manufacturing economy? Instead of importing, well, I don't know the exact stat, but importing 95% of goods, could Guam become a maker of goods and potentially an exporter of goods? So they actually, through some funding through, I think it was BSP, the Bureau of Statistics and something else. I'm sorry,
I think it's
I forgot.
practices.
Okay. Um, they actually hired ASTRO, and again, this is a little bit before me, to do a study on, is it possible for Guam to become a manufacturing economy? And through our work, which again was a little bit before me, the answer was yes, it can be done. There was a lot of different hurdles that would be need to be addressed, but it is possible. From there, it kind of turned into not can we do it, but how would we do it? And so then through GITA, there was another study funded that explored that idea. Like, okay, how would you actually
And
go
that's the
about doing
Guam
this?
Economic Development Authority,
That's correct.
right?
Yeah. The Guam Economic Development Authority, or GEDA, GEDA for short. And so they funded the second study that looked at how would we do it, or how would we recommend that you do it. And that laid out again, a bunch of different hurdles, but potential solutions and a way to navigate through the process to get to the final end result. And once that was completed, it led to the ASTRO team kind of pursuing a contract with the Navy to ultimately fund this vision to build a factory in Guam because the Navy could be the primary customer, but it would have the secondary benefits of being, staffed by Guamanians. And to staff that facility, we have to educate the people, which then means we have to make a campus on or work with the colleges there with UOG to educate the young folks on Guam
Right.
and all these different things. And so yes, we are doing a lot of work for the Navy, but it is ultimately, yes, we're solving Navy problems, but it is to the benefit of the Guamanian people as well. And it's kind of all laid out from this vision initially from the governor, Lilian Guerrero, back in 2021 that is finally coming to fruition now. So after the study with Gita, where they said, first the ask was, can we do it? Then the ask was, how would we do it? And now the ask is, okay, please go do it. So so that's where we are now, is the please go do it. And again, the Navy's funded us. I'm there on the island most of the time, not right now, but most of the time I'm there. And we're trying to build the facility and get the education facility established and get all that in place to start building these parts and solving these problems.
Outstanding. So talk us through kind of where we are today in terms of timeline of going and doing it, if you will. When do you estimate Gamma will be production ready? Kind of what's the status of the facility build out up in Dedido and the industrial park there, and the installation of the major equipment you need to make that into a true production facility?
Sure. The so I would say just to quickly answer the questions up front, we are targeting to have initial operating capacity in April. It depends, schedules are always moving, but the target's April
Yeah,
this year,
springtime frame,
2026.
basically.
Exactly. Springtime frame 2026. And what does that mean? So we have, I don't know the exact number, but let's just say there's 30 different pieces of equipment in the building. I don't know if that's the right number or not, just notionally. To have initial operating capacity, we've identified a small subset of that, of like, what do we need now to get up and running? And there was probably, I don't know, 10 to 15 of the 30 items were like critical, urgent needs to meet that initial capacity. So the way that our sort of funding structure is set up with the program, we started working on this in basically March of this year, and we've ordered a handful of equipment. We've been designing the building, which is 8,000 square foot facility. It's up in Dedido. Right now, as of today, it is a concrete structure, but we have plans to build, walls and floors, plumbing, electrical, mechanical systems, all that's necessary to actually construct a manufacturing facility over the next couple months. And it is a very aggressive schedule, but we are, again, we're kind of there's a lot to be. I'm not saying all this will be done by April. I'm saying the bare bones of it to get machines running will be done.
Yeah.
I'm confident that we will still be building the building while we are working in it. But
Building
to
the
get the
aircraft
initial
while you're
operate,
trying to fly it.
yes, exactly. And so we I'm sure you've probably heard of crawl, walk, run, which is just like a common,
Yes.
you start on the easy stuff and you get higher and higher. We kind of, since we do a lot of Navy stuff, we switch it and we say tread, splash, swim, or
And
splash,
that's
tread,
good for
swim.
you since you were a competitive swimmer and that's
That's
kind of your
right.
bailiwick. Yeah, that makes
That's
more
right.
sense for you.
Yeah, exactly. So that's what we're doing. We're trying to figure out how to splash first, starting with, the basic operating capacity, and then we'll scale up over time to bigger equipment, more capacity, more capability, and then eventually we'll be swimming all out, and we will have, facility will be filled up to the gills with equipment, and there's going to be no space to move, and eventually we're going to need to get another building if everything goes really well. So yeah.
So let's talk about the Navy piece of this. A couple of things. One, does the Navy already have a candidate list of parts that they're looking at of handing over to you to say, here's what we want you to work on, and making these 3D production kind of assets? And then of the list of items on that part, how would you characterize them? Do they have like certain kind of categories, certain kinds of items come up that are in demand to be used? And then can you talk about your relationship with the engineering authorities at NAVC and some of the other program offices that are going to be critical in allowing you to and certifying the parts that you produce? Because without them saying, yes, we approve you to be able to put this gamma mate part onto our submarine or our ship, you're dead in the water. So can you talk about those aspects?
Yeah, yeah, definitely. The last piece of that, which you're talking about, getting qualified to put on a part on a ship, really ties back to what I was mentioning earlier about if you can't measure it, you can't make it. So to simplify that a lot, basically the Navy comes to us and they have, again, the allowables that I mentioned earlier. So we have to statistically prove through a whole bunch of testing that anything we make meets the allowable limits for that material or that part. Um, and again, that's a ton of statistical work and a ton of testing that has to happen. And so, um, I might need you to jump in, Rob, to remind me some of the earlier question parts of the question because there was a lot there.
Yeah,
But
yeah. So
the
getting to the types of parts, have they handed you a list? And then of the parts that are on that list that the Navy's handed you, do you see some common themes? Types
Yeah,
of parts, the way the parts have been made, or different materials that the parts are made out of, the common themes of those items on that
sure.
list.
Yeah, yeah. So I'll tie that in with what the finishing up the last thought with the NAVC folks. So the Navy team, which is primarily through NAVC, although there's a handful of others, have warrant holders, which are effectively the engineering authority to approve anything we do. The They've created a whole bunch of regulations that we have to follow to ensure that these statistics we're doing and the tests that we're doing are standardized and that they are done correctly and measured properly. And to the parts that they're building, again, almost all of these will be metal components. Um, they have released, I always call it the level 7 letter. I'm told it's called the low risk letter is the actual terminology. So if I use the two interchangeably, that's what I mean. And basically, to getting to the parts list, they've developed a sort of threshold on the criticality of the part that says as long I don't remember every single detail on it, but in effect, like as long as it doesn't have a direct impact on human life, which is an extreme oversimplification of what the letter says, the engineering authority on the ship also has the capability to approve that component. Again, that's a
Wow, they've delegated it to the engineering authority on the ship. That's
parts of it,
a huge win. That's a huge
parts of
win
it.
in flexibility.
And it is, and I don't want to misstate it because I definitely oversimplified what the letter says, but in effect, there's a list of if it checks all these boxes, it can be done by the engineering authority on the ship. And again, that's primarily non-critical components that would have no bearing on, human life impact. And so that really leaves them the flexibility, like you mentioned, to uh, to find their own solutions potentially to these parts that are missing. And one of the unique, and I'm getting to the parts list that you mentioned earlier. One of the unique things that we specifically Gamma are facing compared to a lot of the other teams that are doing similar additive production for the Navy, the major difference is that we are working on legacy platforms. So a lot of the stuff they're building today are for new ships, new
Okay,
submarines, new equipment. And in
that's a good
Guam,
point.
there, yeah, and so that we call that new construction, just for like a little bit of a buzzword. That's the new construction. And in Guam, we're way more focused on sustainment of the older
Yes,
platforms.
yes.
There's a couple of new ones there in Guam, but they're mostly the older fleet. Not, not that
We
they're
have
bad or anything, they're
two
just a
of the
little older.
last We have the two last submarine tenders in the United States fleet here, and obviously those folks with the freight cable and whatnot are going to be the people bringing you the business because they're doing the maintenance work on the submarines and stuff like that, as well as their own tenders. And I'm sure there's a lot of parts that the crew of the freight cable can't get anymore because they're the last two of that
Yeah.
type of ship operating anywhere in the United States Navy.
Yeah, absolutely. And I've met with a whole bunch of people from both the Frank Cable and the Emery Land, and I'm making inroads there, and becoming their friends and making sure they know that they can come work with us in Guam. Uh, and yeah, like they have a big long list of parts that is things that they just need fixed, and to be honest, a lot of them are, things have just broken over the years. And it'd be really nice if the door worked, or it'd be really nice if the knob wasn't broken and I didn't stab my finger on the, potentiometer on the inside of the button every time. So some of them are like kind of simple things that just need to get solved, but other ones are like actually significant, like engineering hurdles. And so I keep mentioning impellers just because, well, for a lot of reasons, but in the Navy, on ships, surface ships or subsurface ships, I mean, in airplanes, like literally anything, impellers are everywhere, and they're a common part that fails. And so I guess just to like put that in perspective for people that aren't engineers and don't think like I think, the the number one most used component, I don't really count screws, so I'm kind of, screws probably would be the answer to this, but the number one used component in like the entire world is motors, right?
Mm,
A
yep,
little electrical motors, a little,
yes,
gasoline motors, whatever. They're everywhere. The second most common component is impellers because the motors are connected to the impellers to move fluids. And
yes,
so impellers are everywhere in the world, not just on ships and in the Navy, but they're everywhere. And impellers are traditionally, and from an engineering standpoint, like kind of like the table stakes almost. Like they are traditionally difficult to design and incredibly difficult to build. They're also difficult to 3D print, depending on how you're trying to do it. There's some better ways than others. But it's a common component that most people in the world don't even really realize exist. I mean, there's probably like 15 of them in your car, and there's probably like two or three of them at least in your house. They're everywhere.
yeah,
And in the ships, they're all over the place. And some of these components live in extremely corrosive environments. Some of them just deal with salt water. Some of them deal with acids. And over time, those impellers, you could think of it like, you might throw, a banana down your disposal in your sink, right? Some junk just gets in the pipes and clogs it up and breaks it. There's all these different things that break impellers that are constantly working for like years and years and years, like 10 to 50 years, these impellers have been in use and never been changed out. And so like that's a really good example just because it's constantly needed and it's something the Navy has expressly, asked us about. But there's other common things like brackets
So,
yeah, go ahead.
so let me jump in before you continue to go in, and it's more of a technical question
Sure.
posed to you, the engineer. So, impellers, are those parts usually castings and forgings? And do you see castings and forgings as a common theme across the kind of parts that people want 3D printed because of how long it takes in order to get a production and um, delivery lead time on parts that are made from castings and forgings?
Yes, yes. So castings, 100%. Forgings are a little less common, but still very common. But castings, absolutely. So, again, for the less technically inclined, I'll try to explain what casting and forging is. So, for casting, typically what you're doing is you're taking a molten product, like a molten metal. You're taking a metal, you heat it up really, really hot until it turns into a liquid. Then you take some form of cavity, like an empty space. And that empty space can be, uh, any kind of shape. But if you imagine, I guess like I will use this water bottle that I have right in front of me. So there's a hard shell, plastic around the outside, and then there's an empty space which is currently full of water, but it would be full of air or empty in this example. And you take this hot metal, assuming the plastic was made of something that could withstand the heat, you pour it into the cavity, and the metal fills it up. Then, if you remove the plastic outside, you have a solid metal water bottle shape, right? You wouldn't really be able to put metal water in it, but you get the metal shape out of it. And so, if you take that same idea and you make something more interesting than a water bottle, you can end up with these fan shapes, these impellers that you're talking about. And impellers themselves actually have, again, I might go down a technical rabbit hole here, but the way the negative cavity is made for an impeller is typically through a lost wax process where
Mm,
um, a wax pattern, which is a positive version of that impeller, is basically that exact same impeller but made out of like candle wax for simplicity's sake, and you heat that wax up inside of some hard shell and you melt it out to leave a negative cavity. But to make the wax shell or the wax pattern, usually you have to injection mold it. And injection molding is an extremely upfront, expensive, and time-consuming process to make that wax pattern through injection molding. And it could cost hundreds of thousands of dollars just to make the tool to make the wax.
to make
Um,
the yeah.
yeah, and so like we always talk about replacing castings, which is what we are doing, but we're really replacing the entire manufacturing process of that casting.
Yes, yes,
And so
yes.
yeah, so there's everything on the front end that gets replaced all the way up into the casting. And similarly with forging, forging's where you take something that's not molten yet, but is extremely hot and it's malleable, and you put it inside a mold and you smash it with like hundreds of thousands of pounds of pressure till it fills that space. And so on that same front, uh, with additive manufacturing, there's a couple more steps you need to do to get the actual mechanical strength that forging provides, which is generally considerably stronger than castings. Um, but the difference in the production process is you need like hundreds of thousands of pound presses that can smash that metal into the shape it needs to be in. And then you also need, again, the tooling, similar to what we talked about with
Tooling to
injection
get there.
molding,
Yeah.
the tooling to get there. And so we are replacing the forging process, but we're also replacing the tooling necessary, which is generally the more expensive. Again, I'm taking some liberties here, but it's generally the more expensive part of that process in terms of dollars and mind power and time to make the tooling that eventually builds the part. And so with
Mm,
additive, we skip all that and jump right to the end part because we're building from nothing instead of starting from something and building down. And it just gives us a different way to approach that problem. And as you mentioned earlier, on the time perspective, if you were going to do this from zero with casting or forging, and like a extremely simple example, you're looking at like 3 months of time just to get to the first part in a more realistic timeline and what casting houses would, actually quote you, you're probably looking at 2 years before you even start the process. And
And they're
so,
so backed up now because of
yeah,
many different reasons. So you're on in the back of the line of a 2 year process
yeah, yeah.
to
And now,
get to
yeah, so
a
you're in
cast
the back of the
at a
line.
casting house.
Yeah, or a forging house because somebody else has got one, they got orders in front of you, and then two, we're usually coming in with like needing like I mentioned earlier, there's like 10 of these ships, of a certain model that has this one specific part,
Right.
and no casting house, there's the economies of scale just evaporate and disappear because you're
I'm
building
not going
one
to make
part.
you one. And if
Yeah,
I do make you that one, it's going to be a ridiculous price that you're going to pay for that one uh, casting part there.
exactly.
So incredibly expensive, incredibly long lead time to get that. And they already got a demand on their services. So you're in the back of the line waiting your turn to have that um, made for you.
Yeah, I mean, if you think about it from the casting house perspective, if they're building an impeller for the Navy or they're building some other widget for, I don't know, some medical company, I don't know, just make it up, that's going to build hundreds of thousands of them versus building two or five, the amount of upfront time and the tooling is the same no matter which one you're doing.
Yes,
So do you want to spend 3 months to make two parts, or do you want to spend 3 months to make 100,000 parts? Everyone's going
yeah,
to pick the 100,000 pro part one. And so like
right.
there's this imbalance that additive manufacturing can come in and solve to solve the two-part problem where you just need a solution for a small quantity. But yeah, exactly
Yes,
what you were saying.
yes, yeah. I knew the engineer would give us a really great layman's explanation of the casting and forging challenge that 3D printing hopes to get after.
Yes, yeah.
So let's move on to like the beyond the Navy in terms of
Okay.
Gamma. Uh, so, what does it mean for Guam to host this kind of cutting edge manufacturing capability? And what kind of opportunities can industry on Guam, i.e., something other than Navy or Department of Defense, Department of War assets, can use this for?
Sure. So I'd say the kind of like I mentioned earlier with the kind of intro to what is gamma. What I think what this means for Guam, again, your very high level 30,000 foot view is Guam kind of transitions from passive sort of logistical node to an active manufacturing hub is the kind of the goal that we are, shooting for. And what does that mean for the local people of Guam? And again, you can always, from a high level say jobs and education. Of course, yes, of course it does that stuff. But I think what it really will do is open up avenues of entrepreneurship. So I know that we've already had a handful of this, like every time I'm walking around on Guam or going to meetings and such, someone asks, "Hey, can I come build this thing in your facility?" And the answer is
Yes,
always, it's again, just kind of like earlier, it's like almost always, yes, you can do it. It might not be the right solution, but it's possible. And it gives people on Guam who have a unique sort of problem set a different lens to look through it for solutions. And so, people have asked, "Hey, could we build more storm shutters additively?" I'm like, "Yeah, of course you could, but that's not the right way to make that specific product. But you could do it. Um, so how
because of the
it's
cost involved with it, right?
yeah, well, just generally sh like if we want to talk technical, like for storm shutters, it's sheet metal. Like sheet metal, you shouldn't 3D print. You should use sheet metal for. But
Yeah.
uh, but yeah, the cost exactly your point is like to answer your question through my question is the cost of doing it additively versus just doing it with sheet metal is exorbitantly expensive additively versus pretty expensive with sheet metal.
So again, hence the first M in gamma, materials, right? So
Yes.
understanding what's the right materials for a additive solution is just as important as knowing all of the details on how to 3D print something.
Absolutely. Yes. And so I want to, my hope, I guess, is like the skill set coming from the education side of what we're doing helps train the people to understand, what is the right solution. Maybe it's additive. If it is, awesome. But if it's not, go down the correct path for your application. Um, So we want to give not only the people of Guam, but the companies of Guam the access to tools and the mindsets and the skill sets that are typically only found in pretty major cities or US cities and cities around the world, and really position Guam as a uh, regional leader in advanced manufacturing and not just additive manufacturing, but advanced manufacturing, which is really anything that uses a computer is probably considered advanced manufacturing.
Yeah, any kind of modeling, scanning, CNC machines, et cetera, et cetera, et cetera.
Absolutely. And beyond that, I my hope from the other, 5 years from now or whatever, is that we've been able to demonstrate that Guam, mostly to the DoD's sort of opinion, is that Guam is now a capability of the DoD, not just like a place where they can land the ships and the airplanes and
Exactly.
sleep at night. It's a place where they can actually get stuff done. And the local
Yes.
people are able to manufacture and get stuff done too. And change that kind of mindset that I've also a little bit noticed on Guam is people inside the fence like to stay inside the fence. And I'm hoping that this capability flip-flops that to be more involved in all the people on Guam as well.
Yeah, absolutely. Absolutely. So, um, can you kind of summarize what you see as the impact to readiness? Because you kind of started down that road. The impact to readiness for the current assets and forces here on Guam, as well as for the Department of Defense, Department of War throughout the Indo-PACOM theater, and then by extension, opportunities regionally for industry and companies. Just kind of a summary of that.
From a very high level, I would say the sustainment and the readiness impact is the ability to keep the assets, which in this case, your ships, surface ships, submarines, and in the future, maybe airplanes and maybe some of the other assets from the Marines, if they're coming, the keeping the operations moving. So what I mean by that is there's no dependence on a brittle supply chain to
Right.
the mainland. They can repair or replace parts on demand there on the island. I think that it will find I hear it all the time, sometimes on the news where it's like a ship is in and it's, costing the US taxpayer hundreds of thousands of dollars a day and the ship's just sitting there doing nothing. And so if you want to talk about it from a financial perspective, the sooner we can get that ship back out to sea doing what it needs to be doing, that's a better use of taxpayer dollars. instead of just sitting there. Um, it might be sitting for a good reason, but if it's sitting for maintenance and it's just waiting and not having a part ready, that's a problem. And that's a problem we can, Gamma specifically, can solve. Um, so I think from a very high level, that's kind of the objective there is increase the tempo of operations, reduce downtimes, and keep if you like literally keep the financial ROI up. Keep those ships
Yes.
moving so that there is no unnecessary burden to the taxpayer's dollar.
Yes, yes. So let me take us even a step further into the maybe distant future, but project the capability if this is done right and whatnot. In this theater particularly, the Department of War, Department of Defense is very concerned about a concept called contested logistics, i.e., that
Correct.
you have the tyranny of distance of this blue continent called the Pacific Ocean, and you've got a pretty aggressive, uh, near peer adversary out in this area. And if something should kick off, the planners understand that we can't rely on this nice, uninterrupted shipping flow to resupply. So, therefore, we've got to push more capability forward, more pre-positioned war readiness material, but also war readiness capabilities like this that can actually repair and maybe even manufacturing new capabilities put on the into the fight without that long vulnerable supply chain that goes all the way back to the Konas, because in this next fight there's no there's no guarantee that that's going to be available and that it's going to work like it's worked um, up until now.
Yeah, and I mean, you explained that really well, by the way. So the uh the whole point of being able to be manufactured at the point of need is exactly to what you're saying. If for whatever reason the supply routes and chains get cut, we have to be able to rely on what we have here. And I mean, I'm sure, you've been in Guam a lot longer than I have, but even in the mainland US, like growing up in North Carolina, we'd have hurricanes that would, and not quite the same typhoons you guys have, but we had some serious hurricanes that would knock out power, put trees down across the street. And I remember, when I was, 6 or so, living, without power for like a week pretty much, which again, not nearly as bad as you guys' typhoons. But as
Yeah.
a 6-year-old kid, you start to realize like when all the services are gone, like you're on your own. And so
Yes.
if we build the capability in Guam to build parts for anything that breaks, it gives us a unique capability to sustain longer and not just sustain, but also kind of like obviously there's the worry side of things, the stress of obviously from a national security standpoint, but from any kind of standpoint that when is your time come and due? And the longer and longer we can continue making stuff to solve and fix all the equipment on island that keeps those services going, it'll be beneficial to everybody.
Yeah.
And so I think that's a really good point that you're putting together. And I'm not a war historian, but I always hear the U.S. military described as a logistical machine. And it's like that is its superpower, is that it's able to get resources where it needs to be when they need to be there. And like
Yes.
I feel like in the news you see that, with all the time now when Russia started up in the Ukraine, they were talking about the logistical issues of Russia and Ukraine were facing, and some of them were good, some were bad. And I'm, I'm not a military strategist. And so I don't see it through exactly the same lens, but I'm understanding how it's such a problem. And from
Yeah.
additive,
It's a huge challenge for this Indo-Pacific theater. and what the next um, contingency could look like.
Yeah.
But even more importantly, for the people of Guam, right? So you bring a capability here that's staffed by um, and sustained by native Guamanians. This puts the
Correct. Yeah.
foundation in place to start having Guam seen as this capability in the Pacific, not just for the Department of Defense and Department of War, but for industry, because they're like, oh, there's some smart people there on this island called Guam who doing all kind of interesting stuff when it comes to advanced manufacturing. I wonder if we could do set up a point of need kind of thing for this particular product or this kind of particular product. And it works both ways. It's not just
Absolutely.
from the United States to get into Asia Pacific region, but also Asia Pacific region working backwards to get into the United States.
Yep.
So because of the geography, you're set up well to position Guam, developing this capability and becoming a 21st century tech and innovation hub. It really is possible if this is done correctly.
Yeah, absolutely. And we've actually had very similar discussions with a bunch of folks in the Navy who's like, this is the test bed, right? If we can do it here, we could do it anywhere. And so they've actually talked about, assuming everything goes well here, how can we copy paste this technology or this capability into other remote islands in and around the Pacific? Because
Yep.
of course, the more assets you have diversely spread around, the better your chances are that if one gets taken out, the other ones can still support it, right? Or just the needs of the region. And from a logistical stand or sorry, from an industrial standpoint, just like you're saying, everybody in all these different places, uh, there's tons of smart people all over the place in the Pacific. And if they have the tools there to build things, they will make incredible things that the world can
Yes.
use. Um,
Yes. And I,
solving unique problems in innovative ways because they're coming at it from a different viewpoint.
yes. So I think one of the most exciting pieces of this is, um, this gamma story, if you will. It's not just the machines and the technology. It's really about the people and the careers here in Guam. And that's, what we've been alluding to, kind of building up this capability, not just in terms of machines and stuff like that. Now, you've talked a lot about Gamma being built on three pillars. And interestingly enough, the first pillar is workforce development and education. So, can you walk me through what does the workforce pipeline look like on paper, and how are you turning it into the reality?
Yeah, yeah. So of the three pillars, the workforce one, I mean, they're just like a stool, right? If you don't have one, the whole thing falls over. So the workforce is an incredibly important part of what we're doing. And I think you said it probably better than I've ever said it, right? If we can build it in Guam and we can staff it with Guamanians, the resilience of, the product we're building and the facility and capability we're building, it just gets stronger because it's all local. So what we're doing is working directly with UOG and actually also the Colorado School of Mines, which is where I'm actually at right now, which is in Colorado, Denver, or Golden, Colorado, which is right outside Denver. The objective here is to create a mechanical engineering program on Guam at the University of Guam, but it's effectively a satellite campus for the School of Mines. So,
So, there's actually going to be some of their world-class faculty coming over here and living on Guam at a satellite location. Is that what we're talking about?
That is correct. Yes. So
That's a huge thing because they are one of the most respected STEM higher education universities in the country.
yeah. So I don't know every stat perfectly. I believe Colorado School of Mines is the second largest mechanical engineering program in the country. And if they're the second largest in the country, it's potential they might be in the world. Then and on top of that, they are I don't know. Personally, I would probably put them at the very top of skill sets in additive manufacturing as well, which is a subset domain underneath mechanical engineering. There's, probably eight really good colleges across, at least the US, maybe the planet, where they have extremely high proficiency in additive, and I would rank Colorado at the top of that, or Mines at the top of that. And so I don't think maybe I have understated it, but I don't think I don't mean to. This is like a significant
Huge.
opportunity that is coming to Guam and to the local students there to get a actual Colorado School of Mines degree without ever leaving the island.
Yes.
Um,
Huge. Huge.
yeah, and of course, any graduates from there, I would like to staff up at my facility, but eventually we won't be able to hire everybody, and so that will again give those students opportunities on island to find problems and solutions that they want to implement, careers or sorry, entrepreneur style businesses that they want to start, again, to solve the local problems on the island. And if they decide to leave and go pursue other jobs elsewhere, that's a personal opinion. Yeah, I'm not going to stop them. Go follow your dreams, but we are doing what we can to bring these opportunities to the young folks of the island.
Literally cutting edge education, cutting edge curriculum and professors coming and collaborating with the University of Guam, satellite location, satellite campus right here embedded in the University of Guam. That's huge. Can you talk about like now the next layer? So Guam Community College, what's being looked at there to kind of integrate with them and uh, infuse this kind of curriculum into what's going on at GCC.
Yeah, so we can't talk a ton about GCC right now because we're still in the middle of figuring out all the details. But at a high level, the intent is that they will work to develop sort of operator programs, and if you will, and also to reach down into the
The trained
the
technicians to run the equipment and the machines and all of that kind of stuff,
Correct,
right?
correct. And that
Okay.
kind of pulls us back to the manufacturing operations side of things. And the expectation, in effect, is that um, people with associates type degrees would be operators and technicians in the facility, which are incredibly important and honestly probably way more down to earth in terms of
Yes.
expectations than engineers who are, their brains are in the clouds a lot of times, me myself included. And so the engineers that were graduating out of UOG will be paired up with those operators and the technicians that are actually operating the equipment and saying, hey, maybe this idea you have isn't quite as great as you think it is, engineer with your brain in the clouds. Maybe we should shift it a little bit to think more in reality. And so, me personally, I personally have worked with a lot of operators, and I think I've learned a lot more from operators than I have from engineers, just of, the reality of the world and what's really possible. So, definitely two major skill sets that we're going to have to be building on the island, and the reality versus the pushing the envelope sorts of
Yes.
mindsets.
Yes, yes. Okay, let's go now to the next level. Um, you're working with the Guam Department of Education on K-12, K through 12 kinds of opportunities to introduce this technology and this information early on to the kids so that by the time that they're getting to senior in high school and beyond, they're already maybe tracking careers and opportunities in this area. Can you talk a little bit about that?
Yeah, so a lot of that is also still being sort of formulated and how it's all going to perfectly work together. So this is a little bit forward-looking, maybe you could say, but it's a lot of getting into the classrooms through potential boot camps, local, camps, I guess other camps, not boot camps, where they could get hands-on with this technology and understand it in a very limited capacity, just understand what the opportunities are. And again, the intent is to, as you mentioned, kind of show them different career paths where they could go, how they could transition up into UOG and out into educate or engineering positions in different places that their futures could grow into. So a lot of it, right now I kind of group that into a little bit of a marketing category. But the intent is, as you're saying, to show the local populations what are possible, show the local youngsters mind-blowing capabilities potentially and get their gears turning because as you know, or at least as I know, I have my sister has three little kids and they're all under four and the ideas that they come up with,
Yeah.
are incredible. But me as like an old fart adult is like, I don't know if you could really do that. But it's having those young inspirations, fueling some of the future or a lot of the future is really what it's all about.
Yeah, absolutely. So for those young persons that might be listening, maybe a person down in Agate or up in Jigo or right close to your production facility in Dedido, you know, they might love tech, but really don't see a path for them right now. What's your message to them? What kinds of things should they be studying in school? How should they position themselves to be competitive for jobs
Rob, can you hear me? I
at
think you might
Gamma
have
or
cut out.
broader? Uh,
Oh, there you
are
are. I
you
got
there?
you back. I got you back. Yeah.
All right. So, what should they be studying in school? How can they position themselves to be competitive for jobs at Gamma or anywhere in the broader advanced manufacturing ecosystem?
Yeah. So the best place to start, I would recommend is math, as like a just a ground level skill set to have. It seems kind of, cheesy to just say, hey, learn math, but it really is a foundational capability to understand how to add things together or do complex operations to get to a final result. And I'm starting to realize as I get older, like as a youngster, like I was really good at math, but I was also sort of artistic, not autistic, artistic. Uh, some people might think I'm autistic too. So, uh,
Okay.
but
Thank you for
but
that clarification.
so the as I've grown into engineering and having that artistic background, like I'm starting to realize like how math drives design and can be actually sort of like a beautiful background tool that's driving things forward. And what I mean by that, and like I guess to just really kind of sum that up, is like you should really learn design software, CAD software, computer aided design, CAD. It's a gateway skill that really is used to prove your skill set. You can show your capabilities, how your mind thinks, how it solves problems. And going beyond that, as you're familiarizing yourself with CAD, which there's tons and tons of free softwares for, um, you'll kind of figure out as you start to do that what types of things you're interested in. And what I mean by that is for CAD specifically, there's geometric CAD, which is you want to make gears and pulleys and wheels and shapes that you can easily measure. But on the flip side of that, maybe you want to make organic shapes. And so
Mm,
those are the two different kind of regimes that it falls into. It's either organic or it's geometric. And that kind of will help drive you down a path to understand, what kind of problems are you solving. Generally, generally geometric skill sets are more mechanical, whereas if you'd want something that's more organic, you might be doing something that's more medically related. But in any case, you're learning how to design and solve problems with the computer tools you have here. Um, Beyond that, I'd say, look for local community labs where you can get hands-on equipment, hands-on training with equipment. Me personally, that's how I learn best is just getting my hands inside the gears and the grease to understand how things work and how they operate and tweaking the settings to figure out what's the right setting for my application, which is something we do all the time in additive. And as you're doing that, build a small portfolio of your work. I can't recommend that enough. It's easy to kind of show, like talk to somebody and say, hey, like earlier I said I made or worked on SpaceX helmets, but you don't have a way to prove that. So like I could have made up anything, right? And so I mean, unfortunately, I wasn't allowed to take pictures of that one, so I can't really prove it at all. But as you build that portfolio of all the things you've worked on and tangibly show people, hey, these are the problems I've solved. Here's how I did it. Here's how I thought about the problem. That's really what we want, or what I want in engineers. And so it's it's more of um, people showing, or students or whoever it is showing an initiative to figure things out without being told how to do it or waiting for the
Yeah,
instructions to be handed to them, and like
yeah.
just solving a
Innovating,
problem. Yeah, innovating. Yeah,
innovating.
just solve the
Yes.
problem, and solving a problem, in my opinion, is better than having a perfect skill set on a resume. Like actually being able to do it is better than it just having the skill set that exists. So um, that's kind of what I would say. Just show up and solve problems. And just, I don't know. If you don't like doing that after a long enough time, maybe you need to go sit on the beach and take a relax, but take a little relaxation. But as long as you're showing up and solving problems, don't wait for the instructions, figure it out. And that's what I would recommend.
Yeah, that's great advice. So let's kind of expand. Let's kind of wrap back to a discussion that we had about beyond Department of Defense and Department of War. Uh, applications of this, what kind of opportunities for industry or organizations here on island to take advantage of gamma assets and technologies for it. Because really, as you said before, gamma is not just a United States Navy asset. It really is a Guam, people of Guam kind of capability that you want to do. So let's do like kind of rapid fire ideation in some of these different areas on island that maybe you could come up with some thoughts or ideas on. So the
Sure.
first area, power and water utilities. They face lots of corrosion, aging infrastructure. What kinds of parts or tools could additive or advanced manufacturing help them with?
Yeah, so I mean, with the water systems, we already talked about impellers. I think that's just a, kind of a repetitive one there. For the power authority, I've talked to them a couple times as well, and they have a lot of interest in this as well. And it mostly was surrounding the older power stations. I believe it was the steam powered one that was from the
Yeah,
70s. Um, I think that's the one down by Navy Base. I haven't figured them
yeah,
all
the
out
PD
yet.
power plant.
Yeah. And so what they were really interested in from that perspective is all the equipment in there is from the 70s approximately, and it's degrading over time. It happens. It's just what happens. So we've talked a lot about going in and digitizing the equipment they have there. And so you mentioned earlier the 3D scanning. So that's a technology we have on hand now that we can actually go into any facility or any sort of vehicle or platform and create a digital copy of an existing part. So let's just say there's a gear. I don't know if there'd be a gear in a power plant, but let's just say there's a gear in the power plant that it's getting a little old, a little rusty, a little corroded. We're worried that it might break. We can, without ever taking the component out of service, make a 3D model of that and digitize the physical asset and make a digital version of it, take it to our facility. Again, the power plant, in this case with the gear, never goes out of service. It can keep operating, and we can have that on file so that one, we could either build it now and have it in stock so that if this part that we believe will break does break, we have a part already ready for it. The other option is once we take the digital file and we just put it into our file system, if it does ever break, we have a digital copy of that part already when it was in usable service. So nothing's broken on it, and we can again build it at that moment so that the downtime is reduced. And there's a whole bunch of different other um, parts that might be interesting for the power company as well, from like copper-based conductors that are just hard to find or take a long time to get that we could assess. But I really think that reverse engineering and designing and digitizing of the old technology will be the big savior if it's ever needed.
Yeah, yeah. So, in other areas like tourism and construction, obviously there's a lot of opportunities for rapid prototyping of custom fixtures or signage or architectural components or replacement parts for equipment. So a lot of stuff there for transportation and logistics, a lot of opportunities in additive for support fleet maintenance, warehousing, port and airport systems. Uh, can you talk about how if a business or an organization here on island really wants to plug in the Gamma, how would they do it? And I
Yeah.
said business or organization, probably one of the key ones, like you mentioned before, is probably entrepreneurs. I've got a great idea. I want to start a business producing X. Can I get into a rapid prototype type using additive manufacturing of this idea that I have, this product idea I have using Gamma?
Yeah. So I would say the best way to get in contact, well, right now, the best way to get in contact is really call me or knock on my door. But in the future, the proper method to get in touch with us. So we're basically gonna have two facilities in Guam. There's gonna be the facility up in Dedido, which we've talked a lot about, which I always just kind of say it's my building, which is not really true, but it's my facility. So there's the facility up in Gamma or in Dedido, which is very much focused on production. And so that facility will be doing, effectively contract manufacturing. The machines are there to do specific jobs. The facility that we're working on for the University of Guam, which is also tied in with GITA, Guam Economic Development Authority, will become the best place to really push the limits for early stage ideas. So the production
Okay.
facilities for kind of later stage ideas that are ready for production or larger than just rapid prototyping, it's actual production. At the Technology and Education Center, which will be at the University of Guam, that will be where there's an innovation capability, which will be again through GITA kind of funded, but it will house it's basically like a small lab style version of what we will have in the production facility. So students can use it. Local entrepreneurs are expected to have a space there as well that they could use some of that equipment or have office space. And that would be the best way to actually get access to this technology. And of course, you can always, when we're there, find me, ask me, is this a good idea? Should I do it additively? Additive might not be the right solution. And as we talked about in a lot of different points earlier, it might not be financially the right solution. It might not engineeringly be the right solution. There's all kinds of reasons where additive will be the solution or it won't be the solution. and identifying and understanding the application of how to manufacture it will be the very uh, baseline starting point of where you want to, be thinking.
That's great that you talked about the other capability, kind of an innovation style lab that's being worked on or is going to be worked on there at University of Guam to help with the rapid prototyping and design efforts. But past that, I want to confirm the Dedido production facility. Could a entrepreneur or a company or an organization here on Guam use that for initial low rate production of a particular item before um, basically um, off laning it to their own production facility?
Yes, so for the capability, yes, it's possible. There's a couple sort of logistical hurdles we have to make sure we have to cover with, anybody that we do that work with. But yes, it is possible. So again, facility won't be ready for a little bit of time, but once it is up and operational, yeah, we would be able to accept small run jobs to address those needs.
Awesome, awesome. Well, wow, Alex, you did not disappoint it. I knew it was going to be a great session. Uh, Thank you for your incredible insights. Thank you for making time out of your busy schedule. And we've got to have you back. Spring 2026, when you're production ready and you produced your first part, we got to have you come on back and talk about everything that's been learned in the intervening time as well as kind of what's on the plate now moving forward in terms of production jobs. Thank you for being a guest on the Innovate Guam podcast and sharing your insight about the great work that Gamma and ASTRO America is doing to support the United States Navy and the people of Guam. To my audience, I hope you were inspired and learned something new today. I certainly did. Remember to follow me on all social media platforms, including Substack. Be sure to like, share, and subscribe to stay up to date on all future episodes. And don't forget to check out my Innovate column in the Pacific Daily News, first and third Friday of each month. Until next time, I will see you. And remember, whether at work, at home, or at play, always innovate. Thank you so much.